Today we're going to talk about Chapter 9.7, which is continuing with factoring. And today we're going to talk about factoring special products. Okay, if you recall from a couple sections ago, we learned about multiplying binomials that look like this, where we have the same thing that's added and subtracted. Okay, and we had a result with something where a was squared minus b was squared. That's called the difference of two squares. We also have this where we had a plus b or a minus b squared, which in turn was us just multiplying the same binomial to itself. And we would get a squared plus or minus 2ab plus b squared. This was called a perfect squared trinomial. Okay? Today what we're going to be doing is we're going to be seeing this side now in our problems, and we're going to have to use this in our factoring. Okay, so now we're going backwards. So we're going to have to be able to identify a difference of two squares and identify these perfect square trinomials. Okay, when you're identifying these things, what you want to be looking for are perfect squares. You want to be seeing a variable that can be squared or that is being squared, and you also want to see a number that's being squared. That way you can break it up into the things that are being squared. See, this is a squared. If I figure out what is being squared to get this, I can just go ahead and drop it into my parentheses there. Okay, we'll do a couple of examples, but you want to start training your eyes to see those squares in the problem. Okay, so here we want to factor 16x squared minus 4. Okay, right away, when we see two terms, okay, we know either one, we're going to look for greatest common factor, and that's all we're going to be able to do. Or two, we're going to look for perfect squares. Okay, so here, if I look at this, I have an x squared, which that's a good sign already. And 16, I know, is 4 squared. So actually what's happening here is I'm having 4x, and it is being squared to get that, because then you would square the 4 and square the x. So 4x is what is being squared to get this 16x squared, which means that 4x is our a. Okay, and then here with 4, I know that 4 is actually 2 squared. Okay, so this 4x becomes my a, and this 2 becomes my b. So now I can just use this formula, and I know that the factored form of this is going to be my a, which is 4x, plus 2, and then I have 4x minus 2. And that is my factored form. Okay, remember that we want this plus or minus to be here because then our middle term cancels, and that's what's happening in this difference of two squares. We have no x term because the plus and minus in our difference of two squares cancels out, so that we're just left with these two terms. Okay? Over here, we have 9x squared minus 49. Okay, again, begin to train your eyes. Start noticing perfect squares in numbers. So 9 we know is a perfect square, and x squared is a perfect square. So what is being squared to get 9x? Well, we square 3 to get 9, and we square an x to get x squared. So I have 3x being squared to get this value. Then what do I square to get 49? I square 7. Okay, so 3x is my a and 7 is my b, so I know that this is going to be 3x plus 7, 3x minus 7. Okay, and you can do your plus minus in whatever order as long as you have one that's addition and one that's subtraction, so that that middle term cancels and you get the difference of two sums, or difference of two squares, excuse me. Okay? Alright, moving on to a perfect square trinomial. Okay. Here, if you did not see the pattern, what we have here at the perfect square trinomial is we have some number that's being squared plus 2 times our a or b plus our b squared. Okay? So here, we notice a perfect square. And 49 we also notice is a perfect square. Okay? If you're trying to identify perfect square trinomials, the first and last terms have to be perfect squares. Okay, and then we have to use once we figure out what's being squared, we have to deduce to see if this middle term is able to make it a perfect square trinomial. Let me show you. What is being squared to get x squared? Well, here we have an x that's being squared. What is being squared to get a 49? We have a 7 that's being squared. Okay, now we have to figure out this middle term. Is 14x the same thing as 2 times a times b? So, is it going to be the same thing as 2 times my a, which I've just selected as x, times my b, which I've just figured out is 7? Does 2 times x times 7 equal 14x? 2 times 7 is 14, times x is 14x. So yes, it does. So here, this proves that this is a perfect square trinomial. So, I know that I'm going to have my a plus, because this is a plus sign, plus my b squared. Okay? Now, one thing that I want to tell you, with this perfect square trinomial, if you don't see it right away, it's still okay. You can still use product sum. Because here, if you looked at this, what multiplies together to be 49 that adds to 14, we would have gotten 7 and 7, which would have given us x plus 7, x plus 7, which is that. Okay? Both ways are acceptable. Sometimes using this trick is much faster, but if you can't remember the trick, it's okay. Just use your product sum because that's what we know. And you can use it because you get the same answer. Okay? Alright, moving on to this one. Now, I'm going to erase this formula. You should memorize the formula, PS. Okay, now, looking at this one. We have negative 3y squared plus 36y minus 108. Are the first and last terms perfect squares? No. 3 is not a perfect square. And we can stop our hunt there. We don't have to figure out if 108 is or not. Okay, so now we need to start going back into our toolbox. Well, here I see, you know what? I have a greatest common factor. They all don't have y, but they all have a factor of 3 in common, and in that case, a negative 3. So what I'm going to do is I'm going to pull out a negative 3. Since I'm pulling out a negative 3, I'm undoing the distributive property, which means I'm dividing every term by negative 3. And the result is what I put in the parentheses. I can switch this down. Okay? So negative 3y squared divided by negative 3 gives me a positive y squared. Then a positive 36y divided by negative 3 gives me a negative 12y. And then a negative 108 divided by negative 3 gives me a positive 36. Okay, now let's take a look at this trinomial. Is this a perfect square? Yes. Is this a perfect square? Yes. Okay, so here we're having this y that's being squared, and here we're having this 6 that's being squared. Is this middle term the same thing as 2 times your y times your 6? Why, yes it is. So, that means that I can factor this. I have negative 3 on the outside that needs to stay. But then I have my a minus whatever sign is right here goes in this parentheses, minus 6 squared. And that is your answer. Okay? So, the sign that leads in front of the x is what goes in your parentheses. This was a minus, this is a minus. Okay? Alright, on to solving. Solve 8 minus 18n squared equals 0. Two terms. Whenever we have two terms, the things that we have to resort to are greatest common factor or difference of two squares. That's it. Okay, so, do we have a difference of two squares? 8 is not a perfect square, so the answer is no. So we must resort to greatest common factoring, or greatest common factor, which 5 and 8 and 18, that means they both have a 2 in common. So if I pull out a 2 from 8, I'm going to be left with a 4 minus 18 divided by 2 is 9n squared equals 0. Oh, hey! Look at that! I have a perfect square here and a perfect square here. What are the chances? I mean, seriously. Okay, so what is being squared to get a 4? I have a 2. And what's being squared to get a 9n squared? That is a 3n. Ding, 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 ding. So, this is my a, this is my b. I'm going to have 2a minus b times a plus b. Okay? Here, this 2, if I divide both sides by 2, divide everything by 2, I'm still going to get 0. Those are just going to go away. So that 2 really has no role here. Okay, now I have things being multiplied together equal to 0, so I'm going to take this guy and set it equal to 0. Can you see that? 2 minus 3n equals 0, and 2 plus 3n equal to 0. So here I'm going to add 3n. I'm running out of room. I'm going to come up here. Okay, so I have 2 minus 3n equals 0. I add 3n to both sides, and I get 2 equals 3n. I'm solving for n here, so I'm going to divide by 3, and I get n equals 2/3. That's one solution. My other one is 2 plus 3n equals 0. So if I'm solving for n, I'm going to subtract 2. 3n equals negative 2. Divide by 3. N equals negative 2/3. Okay? And those are our two solutions for this problem. So we did greatest common factoring, difference of two squares, zero product property, and found our answer. Woo! Lots of things going on in that problem. Alrighty, last one, then we'll be done for this lesson. Okay, start training your eyes. Do you see perfect squares? Yes. Okay, this is a perfect square, this is a perfect square. What is being squared here? I have a 3 and an x. And what is being squared here? I have a 2. Minus, so we're going to get a minus here. Is 12x the same thing as 2 times my a times my b? Does this equal 12x? 2 times 3 is 6, times 2 is 12. X. Lovely. So that means that this is a perfect square trinomial. Monomial. Monomials. 3 monomials. 3 terms. Fact. Okay. So since this is a perfect square trinomial, this is my a, and this is my b. If you haven't noticed by now, whatever is being squared to get that number, it turns out to be your a and b. I hope you picked up on that. Okay. So here, since this is a perfect square trinomial, we get our a minus, this is minus sign, minus our b squared equals 0. Well, we'll do it this way. 3 minus 2 squared, or 3x minus 2 squared is 3x minus 2 times 3x minus 2. These are both going to result in the same thing. If I set 3x minus 2 equals 0 and 3x minus 2 equals 0, I'm going to get the same answer, so really all I have to do is solve it once. So I'm going to add 2 on both sides, and I get 3x equals 2. Man, 2/3 is like the lucky deal for today. Divide by 3, and I get x equals 2/3. Okay? So, I want to put this back up here only because sometimes you forget which one you use and when. So I just want to let you know of a pattern, sort of a contrary pattern. Notice that when we have a smaller polynomial, so when we have a binomial, we only have 2 terms, our expansion of it for factoring is bigger. Okay, so we have to go to those 2 brackets. Whereas here we have this trinomial and we can condense it to the binomial. Okay, so we go from small to big or big to small. I don't know if that'll help you remember it. If it does, fantastic. If not, just stick it in your brain and make it stay there. Okay?